Good morning, everyone. I'm Ankit Roy of PCA First Sem. So today I'll be talking about and teaching you guys about heap trees. So it goes. Heap trees. A heap tree is a special tree-based data structure in which the tree is a complete binary tree. Generally, heaps can be of two types: max heap and min heap. Pardon me. So max heap. In a max heap, the key present at a node root node must be greatest among the keys present at all of its children. As you can see below, you can see the root node is greater than all the other numbers. As you can see, the root node is 100 over here, and it is the greatest. Whereas in the case of min heap, the root node is the smallest among all the other numbers present in the tree. As you can see, in the min heap, 10 is the root node which is the smallest. So, a heap tree must follow structural property and ordering property. Also, a heap tree is also all an almost complete binary tree. So you guys must be knowing what is an almost complete binary tree, and you guys know what are the properties of structural property and ordering property. For example, in this there is an example for max heap. You can see here. Let's take an input array, say 10, 20, 25, 6, 12, 15, 4, 16. The first step is to create a binary tree from the array. So we have created. First take 10 and then put it in the tree, and then we need to arrange this tree and make it in the order of a maxi. So how will you do that? Let's see. Now we'll take a subtree at the lowest level and start checking whether it follows the maxi property or not. So here you can see 16 and 6. As we can see, the subtree doesn't follow the maxi property. Here the parent node should contain a greater value than its children node. So in order to make sure that the tree follows the maxi property, we swap the key values between the children node and the parent node. Let's continue and examine all the subtrees from the lowest level to the top level. Now as you can see, we've swapped we have swapped 16 and 20. Now this subtree follows the maxi property and we don't need to change anything here. Next we look at the right side of the branches. Again the subtree follows the maxi property. Let's continue this process. Here again we can see that the key value of the root node is not the largest among all the nodes in the tree. Hence we swap the key values of the root node with the key value of its right children node to match with the maxi. Now after the swap, we need to check the right subtree from the right node in order to see whether it follows the maxi property or not. So finally we can see that it is in the perfect order for a heap tree, max heap tree. And now let's talk about min heap. Consider this example. You can see arrays 1, 5, 6, 8, 9, 7 and 3. So let so min heap, the root node must be the smallest. So as you can see in the left side, 1, 5, 6, 8, 9, 7 and 3. As you can see, 6 is not the smallest, the root node is greater than the children. So what we need to do, we need to swap 6 and 3 so that the root node is smaller than the so that the root node is smaller than the children, because this is a min heap. So as we swap 6 and 3, it becomes a min heap. Whereas for max heap, the root node must be the greatest one than the children. So there are various operations on a heap tree. The first one is insertion. The following are the steps involved while inserting a node into the heap. First, add the node at the end of the array. Keep it at the right place in the heap tree. So insertion, how to do insertion is basically we add the element at the end of the array, and then we keep checking if it's a complete binary tree or not, and we swap it until it goes to its correct place. And the second operation is deletion. The following are the steps involved in deleting a node from heap. First, find the index number of the node that is to be deleted. Take the last node of the tree that at the place of deleted node. And third, keep the node at the appropriate place. Consider the following heap. There are two ways to delete the root node and place the node at its place. The second is replace the node which is to be deleted with the last node of the complete binary tree. You can see the example. First, take the node 76 at the place of the node 22. Compare it with the parent 30. Parent is smaller, so interchange 76 and 30. Now the new parent of the node is 76 of the node 76 is 50. It is smaller, so interchange 76 with 50. Now new parent of node is 76. Node 76 is 100, which is greater. So now the node 76 at the right place. And last one is heap sort. Heap sort is basically an improvement over the binary tree sort. Here are the two phases involved in sorting the elements. Construct a heap by adjusting the array elements, and second one is repeatedly eliminate the root element of the heap by shifting it to the end of the array, and then restore the heap structure with remaining elements. As you can see an example, root element 86 is moved to the last location by exchanging it with 13. Finally, 86 is eliminated from the heap by reducing the maximum index value of the array by 1. The above heap tree is not heap. At first, adjust the heap tree and then continue. The root element 63 is moved to the last one location by exchanging it with the last element 08. Again, the above tree violates the heap. Adjust the heap and then proceed. Root 54 is moved to A5 location. This way, it goes on and fills and sorts and makes a complete binary tree. Thank you.